Hello and welcome back to day 5 of SOL 611. How you doing today? My name is Jamie Espinal. Um, I'm a 6th grade math teacher at ETMS, Elkhart Thompson Middle School. And we're going to have a little fun today. But before we get into all that, I want to congratulate you. I want to really commend you and just really just give you all the credit in the world for making it all the way up to day 5 of SOL 611 Part A. So I know you're going to be ready for Part B. But before we get into all that, let's see what we have in store today. We're going to have a little fun today. All right. And I'll explain in just a moment. But as we've been doing, all right, here is your Nearpod uh, code for today. And as you see, the deadline date. So, um, I want to try and provide some type of feedback. So just make sure that when you submit, you have your name, and then in the options section of the sign in, just give me your student ID so I can try my best to provide some type of feedback to be able to answer any questions or to just give you an opportunity to share whatever it is that you've been doing. All right. So the code is on the board. Remember, all caps is uh, encouraged. I believe that helps it best. And so let's go ahead and get started. All right. So as for the entire week, we've been looking at Part A of SOL 611, where you, the student, will represent the mean of a data set graphically as the balance point. Okay. And the way we're going to get into it is we're going to first off go over day four's situation in involving temperatures of two different cities. And we're going to kind of encompass the whole thing. But if you're not sure what I'm talking about, I really encourage you to check out day four's video. I think it'll help explain what's going on here. But this is kind of like part 2 of day 4. But so involving Kierra, let's just go ahead and read it and go over it. All right. Kierra's second favorite season is the spring. To help her make up her mind, she sent you a text with typical 7-day temperatures. Make line plots for each city showing the balance point and use the balance of data to help her decide what would you tell her. Use all of the information so that she can make an informed decision. All right, so there are the list of temperatures for the week, and Kierra is really trying to figure out what city she should move to. She's got a couple job offers and she's really trying to figure it out. So she wants to pick the best weather. She finds she's that's one of her main reasons in choosing one of the job offers. So the big thing here was, what would you tell her, right? And use all the information so that she can make an informed decision. So you were supposed to make line plots of each city, right? So we're going to go through it step by step. For New York, we're going to kind of skip along a little bit for San Francisco, but let's go ahead and get into it. All right. So here are the temperatures for New York. And again, as I mentioned in previous videos, you really want to try your best to uh, organize your data, right? That's why line plots are really cool. Slashing out whatever you do enter, right? So 74 and 72, you put an X over each. And because there's a 74 already, if you have to put another 74-degree temperature, well, you're kind of putting X's on top of one another. All right, and here is that process here. All right, and here's what we're looking at when it comes to the temperatures in New York. Okay, so we had to find the mean. If you want to get the balance point, you have to calculate the mean. Okay, and so you have to get that sum, right? And after you get that sum, you're going to divide it by 7. All right, so with that being said, what I want to do is quickly, okay, go over, and you got a little sneak peek there of what we're going to be talking about in a second. But I want to just give you another encouragement to use Desmos with this calculation because it's very advantageous and you can kind of get a visual of what we're talking about, right? So I'm going to go ahead and enter these um, temperatures and I'm going to keep them in a parentheses, right? So I saw 68, you're going to add in 69, so 68 plus 69 plus a couple 70s and just making sure that what you enter is accurate. A couple 70s, a 72, and a couple 74s. Okay. Now notice what happens. All right. When you close the parentheses, you get the sum. Okay. A mistake that's typically made is people start dividing as soon as they enter in that final number. Right. But you got to get the sum first. Right. Which is why using the parentheses is good. Remember PEMDAS. Right. Everything inside the parentheses is done first before any other operations are done. Okay. In this case, we find the sum of all those numbers, and then we're dividing, and I love the visual here, right? It's the division of the entire sum here. So there were 7 temperatures, so we're going to divide by 7. And when you do that, we have a balance point here, 71. Okay. So that is our process here. So we have our sum of 497. We divide by 7, we get 71. And that is the balance point, right? So there we have our balance point, perfectly balanced. The left side doesn't teeter to the left nor to the right, right? It's perfectly balanced. That's what's nice about calculating the balance point, right? Then we wanted to find that balanced distribution, right? So we're just going to kind of see if this balance point is accurate, right? So we have one point that's 1 unit away. We have another point that's 3 units away and one right on top, same distance away, 3 units away, okay? So that's the right side, the numbers that are greater than, the data points that are above our balance point. And when you find the sum of those 3 numbers, we have 7. So then we got to check out our lesser than uh, amounts, right? Our data points that are less than the balance point. And here we have our 1 unit away. We have another one that's 1 unit away. We have a data point that's 2 units away, and then we have a data point that's 3 units away. And when we find the sum of those distances, it equals 7. So therefore, we know that our balance point is accurate. Okay. So that's the story that was told with about New York involving the temperatures in the spring. So again, we're just going to kind of skip along with San Francisco. Same process. All right. And there's your line plot for San Francisco. And now we got to find that balance point. So we got to find the mean, right? So we find the sum, we add it all up, we divide it by 7, and the balance point for San Francisco is 68. So there is our balance point there, right? And then we find our distances for those numbers that are greater than those data points that are above our balance point, and we find the sum to be 5. And then on the other side, we find our sum to our distances, and our sum is also 5. So we know that our data is balanced, all right, and it's distributed, and our balance point is perfectly placed. Now, the question was, well, those that's involved in the spring, and prior to that, we talked about the fall. Now, if you look at all of this information, right, you can see, or you were supposed to form an opinion or give some advice, and here you can see that there's a lot of information, a wealth of information, right? Um, this should give you an opportunity, which you should have done on the day 4 submission, and how you thought she should go. All right, and there really is no right or wrong answer, right? I did that intentionally because this is about reading data. This is about interpreting it. This is about telling a story. This is about being able to use information, and in this case, for someone's well-being, right, and choosing the right job. Well, our median, we talked about mean, median, and mode wasn't necessarily You didn't have to do that for this specific assignment, but it was encouraged if you really wanted to form a good opinion here. So here's all of this information, right? As you can see, right? And again, there's really no wrong answer. If you want it to be, if Kierra wanted it to have more variety, a little bit, a bit of a difference between temperatures. There's a bigger variance in temperatures when it comes to New York for the spring, and there's a slight difference in temperature. It's a little warmer in the spring, right? Whereas when you look at the fall is almost identical for San Francisco. I mean, if you look at first off the mean, right? We have a mean of 69 in the fall, and it was 68 for the spring. And so 1 degree difference, uh, pretty much the same, right? And then if you really like those temperatures, well, here we see that it's pretty much the mean, median, and mode in that same temperature. And so you might have said, well, if you really like fall, Kiera, and that's your favorite um, season, well, the fall is almost the same exact thing as the spring of San Francisco. So you're kind of getting a 2-for-1 deal. Um, and there's not a huge difference with New York, but it is warmer in New York in the spring. So if her favorite temperature was, um, I mean, her favorite season was fall, um, maybe San Francisco was the better way to go. You might have said, well, you might want it to be a little warmer, and you could have expressed those central measures, the mode. Oh, and by the way, real quickly before we go too far, here you see the mode. There's two modes here, right? Because we got two 70s here and we got two 74s here, right? So what we call that is it is bimodal, right? It has two modes, totally uh, allowed. That's what the data says, right? There's two modes, and that's true. So, um, there's a lot of ways that you could have went with this. Here you see there's a greater variety in the temperatures, right? Here the distribution is 7, right, for New York. So saying that the temperature differs a little bit more in the spring, whereas it's tighter. It's a little closer in the fall when it comes to San Francisco. So a lot of information, right? Our balance point, our middle number, and our most frequent number, right? In this case was 66. All right. So that is that. Okay. And I really, really look forward to reading your advice. Just do your very best, right? And um, and remember to submit, submit, submit. All right. So that was our independent practice for yesterday. Let's talk about what we're going to do for our problem of the week, right? Because this is day 5 here, right? So here's what I want to see from you, okay? So I want you to survey at least 3 people in your household and document the results, all right? So you're going to do the following. You're going to ask someone, how many push-ups do you think you can do from your knees in 10 seconds, right? Now, this right here is very important because I would really like for our data to be consistent. You might say, well, I don't have to do them from my knees, right? And I get that, okay? But what I really want to do is give ample opportunity where everyone is doing it on the same level, right? So our data can be totally consistent. Because what I would like to do is get this information and compile it, put it all together with everyone that submits. Okay, so doing it from push-ups from the knees. All right, very important. Okay, but how many push-ups do you think you can do? Hey, if you guys want to do it a separate survey test on your own, fine, that's great. If you don't want to do them from your knees, but just for this survey, just for this experience, it's encouraged. All right, and then you're going to get your stopwatch, whether you got it on your phone or whatever, and you're going to record the number of push-ups on your stopwatch. Okay, so you're going to go boom, countdown 10 seconds. Once time is up, stop. Right, so first it's going to be part A. How many do you think you can do? Right, you're going to record that number, and then you're going to actually test it and see, all right, well, how many do they actually do? Okay, and so then you're going to create separate line plots for each of those things, okay? And you're going to find the balance point for both of them as well. And these directions are in your Nearpod, okay? So you'll be able to go over it. But if you want to write these down in preparation for it, by all means, pause it, write it down, go for it. And then you're going to answer these 3 questions, right? So we have our writing portion of the Nearpod as well, answering these questions. Number 1, what does the data tell you about those who participated in the survey, right? So basically comparing what they thought they would do versus what they actually did, right? And then 2, how similar or different was the estimated line plot compared to the recorded, right? So what about the line plots that you put together, right? How different were they, or how similar were they? And did the results surprise you? Again, we have very open-ended questions here. There's no right or wrong answer, right? This is you and your interpretation, right? Based on the central measures of tendency, based on the balance point, based on doing those things to help you form an opinion and have an accurate assessment based on data. Okay, very important that you do that. Okay, now here's a look at what those the template is going to look like when you get into your Nearpod, right? As you can see, it's 1 through 13. All right. Remember, it's only 10 seconds. And so I put a limit there. I wasn't sure how high to go, but 13 is the max. And so I'm not sure if that's going to be a mistake or not, but I tried doing as many as I can in 10 seconds. Boom, time stops at 10. And it's really hard to even get past 10. And so we'll see what happens with that. All right. Um, but at the end of it, you're going to have a survey as well. And the survey is going to be related to you, right? How many did you think, right? Not everybody, but you yourself. You're going to tell me in the survey, you're going to answer the questions. How many did you think you were going to do? All right. And then how many did you actually do? Okay. And so don't forget the survey portion of it. Okay. And then finally, you can share your experience, right? So you will go to Flipgrid, as you can see.com, and put in RPS POTW problem of the week push-ups, right? And that you can share your experience, right? I'm hoping that it's gonna be fun. Um, you'll probably have some people that think they can do 20 in 10 seconds, but they end up doing like 2. Who knows what's going to happen, all right? But I really encourage you to share your experience, all right, in our day 5 of this series, all right? And I really look forward to hearing from you and seeing those experiences recorded. How did you do? If you want to share your line plot on camera, if you want to share your data, if you whatever it is that you want to share with your colleagues, please by all means go for it, okay? And I look forward to it, all right? I want to thank you again for tuning in and for checking in, and I congratulate you and I encourage you to keep pushing, okay? Keep challenging yourself, keep going after your education, because remember, hard work always pays off, all right? That's me. I'm signing out. That's all I got. I'll talk to you again at another time. All right. And take care and God bless.